In this video, I'm going to review the rules of exponents. All right. So let's first give some examples of the usage of exponents. Now, it's important to remember that exponents are nothing more than an abbreviation. All right. Sometimes you will learn something in a class and it's nothing more than a definition, and everybody is trying to figure out what there's that they think there has to be some deep, brilliant concept, when all that really happened was somebody got lazy having to write something repetitively, and so they developed a shortcut. All right. Now that's important to know, because some of the rules I'm going to show you, if you ever blank out and forget some of them, keep in mind that you can always ask yourself, what is this an abbreviation for? And that will help you to derive the rule on your own in a few seconds. And I'll give you some examples of that. So 3 with an exponent of 4, that's nothing more than multiplying 4 3's together. X with an exponent of 3, that's nothing more than multiplying 3 x's together. All right. And let me show you now what I mean by those rules. So first I will write out the rules, and then I will explain a little bit. I'll talk about them so you have a deeper understanding. Okay? If you have a power multiplied by a power, that's equal to a single power where you add the exponents. If you have a quotient of powers, that's equal to a single power where you subtract the exponents. All right? If you have multiple levels of exponents, such as this, then you could make a single power with a product of the exponents. All right? So let's stop there and talk about these. So remember what I said, that exponents are simply an abbreviation. Okay? It should be clear. Let's look at the first one. It should be clear that x to the a represents you've got a x's multiplied together, right? And then x to the b, you have b x's in that parenthesis. Okay? Well, how many x's do you have total? Well, you have a in the first parenthesis and b in the second. Okay? So that's how you can help to derive this on your own if you ever forget it. Okay, or you get it confused with the quotient rule. All right, let's think about the quotient rule. All right, so for that one, you have a x's on top. All right, and then on bottom you have b x's. Right, and you may recall from your algebra class that when you have factored forms on the top and bottom of a fraction, that you could cancel like terms. All right, so suppose that we went ahead and did that. So we have a different quantity of x's on top and bottom. So let's say that b was the smallest number, so we would cancel all the b's on the bottom, and then we would get rid of b x's on top. All right, and then how much would we have left? Well, we would have the difference of a and b, and that's why that's that rule. Okay, now I'm going to talk about what happens if the a minus b gives a negative value. I'm going to talk about negative exponents shortly, so hold that thought. And then for the last one, so again, thinking about what the abbreviation stands for, we've got a packet of ax's. Okay, and how many of those packets do we have? Well, we've got b of them. Okay, so if we have b, a quantity b, a b number of packets of ax's, then clearly we have the product of b and a. That's how many x's we have total multiplied together. All right? So hopefully that helps jog your memory on that stuff. Now let me talk about negative exponents, zero exponents, and fractional exponents. All right? I'll go ahead once again, I'll give you the answer, and then I'll discuss how you can understand it a little better. So if I have anything to the 0 power, that is 1. Okay, now this is certainly true for x not equal to 0. Okay, there's some debate and disagreement on what 0 raised to the 0 power stands for, but as long as you don't have 0, the verdict is in. It's always 1. All right, if you have a to the negative something, let's say a negative k, that's equal to 1 over x to the k itself without the minus sign. All right, and then if you have x to a fraction where a and b are integers, that's the same as a very specific root, the bth root, okay, where let's say if b was 2, it'd be the square root. If b was 3, it's the cube root of x to the a power. All right? So some examples of that would be that, for example, 2 to the 0 power is 1, 3 to the minus 4, 2 with an exponent of 0 is 1, 3 with an exponent of minus 4 is 1 over 3 to the 4. If you want to be fancy, that's also 1 over 81, of course. And then the last one, let's say we had 5 to the 7 thirds. That's equal to the cube root of 5 to the 7. And you may or may not be able to simplify that. Okay? I'll just tell you that it's 5 squared cube root of 5 if you're interested, although that's not the topic of this video. So you could also simplify it further to 25 cube root of 5. Okay? But let me now talk about why these blue formulas are the way they are. Now, I mentioned that I said that exponents are abbreviations, all right? And the way that we define 0, negative exponents, fractional exponents, they're definitions, okay? Now, let me bring that down to size. A definition is something that people agreed on. Again, it's just somebody just made up a rule. They defined these exponents to behave a certain way. So again, there's no deep philosophical concept here that you're missing. Okay? Let me show you why these are the best definitions. Okay? It's because they just fit the best with the previous rules that I said. Okay? A lot of times people will think that x to the 0, that 0 would be a good candidate for that definition. Let me show you why that would not make as much sense. Okay? Suppose I had x to the 4 divided by x to the 4. All right? Now, according to the quotient rule I just talked about, this is 4 minus 4, which is x to the 0. All right? Now, we also learned from algebra that whenever you have the numerator and denominator are the same, as long as they're not 0, that's equal to 1, right? So that fraction is 1. Okay? So can you see how this definition integrates the best with the quotient rule? All right? Now, there's similar reasons why the other two have to be the way they are, because if they weren't, again, they wouldn't integrate very well with the other rules that we have. Okay? So, just know that they they don't have to be this way, but these make the most sense.